Welcome to chapter 7. In this chapter we are going to dive into another important concept, that is operators in Java. These tiny symbols may look pretty simple. Whenever we need to add two numbers, compare two numbers with each other, that is finding the greater and the smaller, or assigning a value to a variable, or validating any conditions, that's when we are going to use operators. In this chapter we'll break down operators into clear and their functional categories, like arithmetic operators for mathematical operations, assignment operators to assign or update a specific value, relational operators to compare two values, logical operators to work on the compound decisions like and or, unary operators to work on single variable, that is a single operand, bitwise and shift operators to work on low-level binary operations, ternary operator for a more simple conditional expression, and Instanceof operator to check which class an object belongs to. We'll discuss each of these operators type with simple example to understand how they work in real-world use cases. By the end of this chapter, we should be able to use operators comfortably in our Java code, combining them to build logic, make decisions, perform calculations, and even optimize our code. Let's get into it, shall we? Let's start with what are operators in Java. In Java, operators are like tools which help us perform operations on data, whether it's math, logic, comparison, or assignment. They help us write simple expressions like total is equal to price plus tax. So here the plus and the equal to are the operators, and we can also have a condition like if age is greater than 18. Here the greater than is the comparison operator. These may look like small symbols, but behind the scenes they are doing a lot of heavy lifting. Let's have a look at different categories of Java operators. We can group these operators based on what they do. Let's start with arithmetic operators. These are used to perform basic mathematical operations like the addition, subtraction, multiplication, division, and the modulus, that is getting the remainder of the value. Then we have assignment operators. These are used to assign values to a variable. You can also perform combined assignment by using the arithmetic operators here. So here add equal to, this is going to add the value and then assign it to it. Similarly, you can have subtract and assign, multiply and assign, and divide and assign. Next are the relational operators. These are like the comparison operators. You can use these to compare two values and the output is going to be either true or false. Between two values there could be different comparison operators like the equal to, the not equal to, the greater than, the smaller than, the greater than or equal to, the smaller than or equal to. Next are the logical operators. These help us combine different conditions using logical gates, that is logical and, logical or, and logical not. Then comes the unary operators. These work with just a single operand. It is handy when you just want to increment or decrement a specific value. So you can do it by the increment operator or the decrement operator or the unary plus or the unary minus or the logical not. Then comes the bitwise operators. Bitwise and the shift operators, they work on a low level task. So this is not something you may use very often. Bitwise operators works directly on the bit level. It is great for performing critical and low level operations like we discussed, and they include the bitwise and, the bitwise or, the bitwise XOR, and the bitwise not. Then comes the shift operators. They shift the certain number of bits to the left or the right, and this is used in fast mathematical tasks. Shift operators include the left shift, the right shift, and the unassigned right shift. Then comes the ternary operator. This is a quick way to check a condition. We'll be exploring the concept of conditions in the next chapters, but for now let's just remember ternary operator is a quick shorthand for if-else condition. That is, it is going to help you evaluate a condition. So the operator works like question mark and colon. This is the condition here, A is greater than B. So if this is true, then max value is set to A, and if this is false, the max value is set to B. So that is how ternary operator works in a single line. And then we have the Instanceof operator. This is used to check if the object is an instance of a particular class. That's about the operators. To summarize, operators allow us to perform all kinds of operations on data and variables. They help us perform mathematical, logical, comparison, and type checking operations while working with variables. And it is very important that you understand the purpose of of these operators so that you can write much better and efficient Java code. Let's quickly go through the code example for it. I'm going to create a new class for this particular chapter, and I'm going to add a main method for it. And here we have a simple blank program, and let me add some print statements here for each type of operator. Now let's discuss how to work with arithmetic operators. For that, let's first define two variables. Let's keep it simple, and we have two int variables, that is a is equal to 10 and b is equal to 5. And here we can perform different types of arithmetic operations like the addition, subtraction, and let me quickly add some statements here to perform these arithmetic operations. So here you see this is the addition. You're adding a plus b, and you're subtracting b from a, then you're multiplying, you're dividing, and here is the modulus. Now let's just save the program and run. So here you can see the addition is 15, subtraction is 5, multiplication is 50, division is 2, and modulus is 0. Because 0 is the remainder, we can divide 10 by 5. So that is how arithmetic operators work here. Now let's quickly go through assignment operators. First, let's create a simple integer variable, and here you can print out its initial value. And now we can try performing some different assignment on this. So let's say c plus equal to 5. Now this is a compound assignment operator here. This is a simple assignment operator here. So what this is going to do is, this is going to add 5 to c and assign its value to c itself. Now let's just quickly print the statement here. Let's do one more assignment here. Let's try multiplying c by 2. Let's again try printing the value of c here. Let's save the program and run. Now here, let's observe the output. Initial value of c. Now here, initial value of c is 10. After adding 5 to it, that is going to be 15, and that is working as expected. And currently the value of c is 15. When you're multiplying it by 2, that is going to give 30. So this is how assignment operators work. Now let's quickly go through the relational operators here. We have already defined a, b, and c. Let's use them to compare the values between each other. Let's quickly write some print statements here. So this is how you're going to use the operators. So a double equal b. So this is going to check if the value of a is equal to b, and this is going to check if the value of a is not equal to b. This is going to check if a is greater than b. This is going to check if a is smaller than b, and this is going to check if a is greater than or equal to b, and this is going to check if a is smaller than or equal to b. And this is all going to return in true or false. The output of a relational operator is always going to be boolean. A is not equal to b because the value of a and b, they are different. A is not equal to b, that is true because that is a true condition. A is greater than b. A is 10 and b is 5, so a is greater than b, so that is a is not smaller than b, that is false. A is greater than or equal to, it's either going to check if the value is greater than or equal to. So in this case, a is greater than b, so that's the reason it's returning true. The other condition is false. So that is how you're going to use the relational operators. These are very helpful while you're defining conditions for your program, as we'll see in the upcoming chapters. Now let's quickly go through the logical operators. First, we are going to create two boolean variables, that is x equal to true and y equal to false. We can write simple print statements to check the logical operators. So here, this is x and y, this is x or y, and this is not x. Let's save the program first and see what is the output. So here you see x and y is equal to false. So true and false, they are always going to be false. True or false, that is going to give you true. That is how you're getting true value here. And not x, that is going to inverse the value of x. Currently it's true, so it is going to set it to false, and that is how you're getting false. So that is how logical operators work. Now let's quickly go through unary operators. First, let's create another variable, int d is equal to 5, and let me quickly write a simple print statement to print out its value. Let's say you want to increment the value of d. You can simply write d plus plus. You can write d equal to d plus 1 or d plus equal to 1 or just d plus plus. This is going to add one number to this integer. Let's quickly write a statement for the decrement operator, d minus minus. So this is going to subtract 1 from the d value, and let's quickly write a print statement to print out d. Let's save the program and run. Now you can see the initial value of d is equal to 5. That is expected. Now this is where the value of 5 is incremented by 1, that is 5 plus 1, and that is how you're getting 6. And then we are decrementing it again, so that is like d minus minus, so current value is 6, and that is how 6 minus 1 you're getting 5. So that's how unary operators work. Now let's quickly go through the bitwise operators. You may not use the bitwise operators quite often. Let's create two new variables for it, and let's add some statements to check the bitwise operation on it. This is the bitwise AND, this is the bitwise OR, and this is the bitwise XOR, and this is bitwise NOT. Let's save the program and see what happens. Bitwise operations are happening on the bit level. We are currently looking at just, so that is how you're getting these values. We don't have to worry about the bitwise operators just yet. We will definitely explore these concepts once we reach there. Let's quickly go through the ternary operator. So this is like the most simplest condition you can use. So we are creating a new int g, and here we have a is greater than b. So currently a is greater than b, so 10 is greater than 5 obviously. So int g value is going to get the value of a. So if this condition is true, g is equal to a. If this condition is false, g is equal to b. Now you can simply write the print statement to print out the value of g and save the program and run. So this is 10 because a is greater than b here in this case, so that is how g is getting its value from a. So let's quickly go through the shift operators as well. We have created a new variable for it, and here these are the shift operators. Left shift, this is the right shift, and this is the unassigned right shift. These operations also are happening at a bit level. Let's not worry about it right now. Let's just save and run and see what the output is. So we are getting 16 and 4 and 4. We will spend some time understanding how the bitwise and shift operators work on the bit level sometime in future. We don't need to worry about it right now. Let's quickly go through the instance of operators. So let's say we have created a simple string str and its value is hello world. Instance of operator, it is going to return a value of boolean. So you are creating a new boolean variable here as a result, and it is going to apply instance of on the variables str instance of string. So we are currently checking if this str variable is the instance of a class string. To see the output, we can write a simple print statement. Is str an instance of string? Let's save and run the program. So this is true because in this case the string is indeed an instance of str. So that is how you're going to use the instance of operators. Now let's quickly go through some of the best practices and tips while working with operators, because operators are indeed powerful concepts, and when used carelessly they might cause a lot of bugs and issues in your code. Use parentheses for clarity. In this case we have used parentheses to group together the operation. So always use parentheses to make the order of operations clear, especially in the complex expressions. This helps avoid confusion and ensures that your logic is executed as you want it to be. Avoid magic numbers, avoid hard coding values in your code. Instead, convert them to variables. That makes your code much more readable and maintainable. And be cautious with the division operator, because integer division in Java drops the decimal part. So whenever you're working with division, make sure you're using double or float for much more accurate results. Don't use the relational equal to operator for comparing values. They actually compare their memory addresses and not values. You can use the equals method to compare two different objects. Use increment and decrement operators in a clean standalone line to avoid confusion. Be aware of the operator precedence while you're grouping together multiple operations. It also is a good practice to encapsulate them into parentheses to define the order of operations you want to perform. Keep complex expressions simple. Avoid long expressions with multiple operators. Break them down into different steps so that is easier to read and debug as well. Use a ternary operator for simple decisions. The ternary operators are going to help you define one line conditional statements. So use them whenever you need to perform any simple decisions. And that is about this chapter. To wrap it up, we explored a very important concept today, that is Java operators. We learned how to handle basic arithmetic operations using arithmetic operators, how to assign and update values using assignment operators, how to compare different values using the relational operators, how to create compound conditions using the logical operators, how to increment or decrement the values using unary operators, working at bit level data using the bitwise operators and the shift shift operators, defining ternary operator for clean and single line conditional statements, and how to test the object type using the Instanceof operator. We also discuss some of the simple yet effective best practices while working with operators. Understanding when and how to use operators is very essential, and it is going to help you a lot in your programming journey. In the next chapter, we will be exploring the concept of expressions, which you could consider an extension of this current chapter on operators. Expressions are basically how Java combines variables and operators together to give out a certain result and do something meaningful. We'll learn how expressions work and how Java evaluates them. And that's about this chapter. Till I see you again in the next one. Cheers.